Welcome to the next video. In this particular video, we will be focusing on more integration using substitution. The previous video we started with substitution, and I hope this will be able to help. So let's dive deep again into doing the U substitution. So remember, we use U substitution in composite functions. So therefore, by using U substitution, we make the integral simpler for us to use. So if you look at this, we can't really manipulate this or expand it. So therefore, we use U substitution in the expression in the root or the one that is raised to a particular power. So we let U equals to x to the 4 plus 1. We take the derivative of U with respect to x. So this becomes 3x cubed dx, and now you can see that there is some form of a relationship between this 3x and that one over there. So therefore we go du, we cross multiply the dx, so this becomes x to the 3 dx. And because we've got a 2 here and not a 3, what we'll do is just write this expression. So cross multiply the 3 down again. That becomes that particular expression. So therefore, we'll rewrite the integral again. So now this integral, because the 2 is just a constant number, we can keep it on the outside. And therefore, this expression can be written as x to the 3. This becomes x to the 4 plus 1, all raised to the half of dx. And I want you to notice again, once this expression is in this form, this part here will then be u, and this part here, which is x dx, as it is combined together, the x dx, we are able to then substitute du over 3 in place of that. So let us continue with this particular problem. So what we'll do, because of that expression that we have, and there is a fraction there, we will then rewrite this as, we'll then rewrite and take the u to the top. This becomes u to the half, and this x dx will be replaced by du over 3. And remember, we had the 2 on the outside. And because these are constant, we can rewrite the integral as 2 over 3, the integral of u to the half du. So now this substitution is really saved us and has made this integral so much easier to do. So therefore, this can then become 2 over 3. We can then easily take the integral of that, which will be u. If we go plus 1, this is 3 over 2. Let's create some space. This will be 3 over 2. Obviously, we can multiply by the 2 there and multiply by the 3 over there. And therefore, this becomes plus c. So what we can then do with this, we can just try and simplify this expression for ourselves. And once we simplify this expression for ourselves, then it becomes a lot more easier. So we will see that the 2's will give us 4 and this will give us 9. If we substitute back what u was, this becomes x to the 4 plus 1 to the 3 over 2 plus our integration constant 2 there. So that is something which is quite beautiful to do, and I hope that you guys understand it much better there. So let's do just another example related to this. Now let us do another question which has a level of difficulty which is a bit different. So in this expression, please put a 2 over there. I think that expression is missing a 2. So therefore, in this expression, we will try to use u substitution again because this is a composite function. So we let u equals to 3x squared minus 1. And therefore, we take the derivative of that, which is dx. And therefore, we can see that the derivative of this is merely 6x. All right. So if the derivative of this is indeed 6x, we can therefore rewrite this expression as du, and you can see that we don't have a coefficient before x, so we'll divide that by 6, and this becomes the dx over there. So therefore, this expression becomes a little bit easier to do. Okay, so now focusing on this, we can then come back to our integral and be able to simplify it for ourselves quite easily. So our integral then simply becomes u to the 5, and therefore this is then du over 6. And because this is du over 6, we can then easily work out what that integral is. So this will be 1 over 6, and therefore the integral of that will be u to the 6 over 6 plus the constant of integration c, and therefore by simplifying this expression we are able to get u to the 6 over 36, and then what we need to do is substitute back what the 6 is, and therefore we will get our solution as 3x squared minus 1 to the power of 6 all over 36 plus our constant for integration. I will stop this video over here. You will see that we will deal quite a lot with the u substitution, especially in functions, in integration of trigonometric functions, and also other functions that we'll come to deal with. Just a reminder, it is fundamental to know when to do the u substitution, and you normally when you do it when you've got a composite function where the one part looks like a derivative of the part that you're going to be making become u. So using u substitution does make it so much easier. So in the next video, I will then start doing u substitution involving trigonometric ratios. I hope that you enjoyed this, and we hope to see you in the next video.